Hello everyone. So today we're going to continue our work with statistics, but we're going to specifically look at normal distribution. And normal distribution I think is really interesting. I hope you feel the same. So, looking at normal distribution. All right. Normal distribution has data that varies randomly about the mean. Has something called a normal curve, also known as the bell curve, because it kind of looks like a bell. In normal distribution, 68% of data fall within one standard deviation of the mean. And a lot of things in life follow this normal distribution or bell curve. And it's kind of, it's not a phenomenon, but like something that we can base a lot of random events to fall within this bell curve. So 68% of data fall within one standard deviation of the mean. The center is the mean, so if that's our mean right there, 34% would be within one standard deviation above, and 34% would be within one standard deviation below. So in total, 68% of data is going to fall within one standard deviation of the mean. Now, 95% of the data falls within two standard deviations of the mean. So an additional 13.5% is between 1 and 2 standard deviations, and 13.5% of the data is between -1 and -2 standard deviations, or below the mean. That adds 27 to our 68, or a total of 95% of the data is within 2 standard deviations of the mean. Now, the really cool thing is that 99.7% of data fall within 3 standard deviations of the mean. Another 2.35 standard deviations of the mean, 99.7% of all data lies. Meaning that if you're outside of those standard deviations, you are considered statistically significant because it is so different from learning that 68, 95, 99.7 rule is key because you need to know those numbers as you go on. The following normal distribution describes the repair times for a local auto shop. Answer the questions below. What is the mean repair time for the auto shop? Remember, the mean is the middle number, so the mean time is 102, and I'm assuming this is minutes. What percentage of repairs take between 84 and 120 minutes? So between 84 and 120 minutes, we have 34 and 34%. So when we're looking at a bell curve, we'll just add up those percentages. Or since we know they're both one standard deviation of the mean, we know that's going to be our 68%. 34 plus 34 is 68. What percentage of the repairs take less than 2 hours? So 120 is 2 hours. So this is 2 hours. And sometimes you're going to have to convert. So what percentage is less than that? Well, we know this plus this is 68. Plus 13.5 is going to give us 81.5. Plus 2.35 gives us 83.85. So 83, almost 84% of all repairs take less than 2 hours. All right, what percentage of repairs are between 84 and 138 minutes? So now we're going from here to here. Well, we already know that these two add up to 68, and then we're going to add our additional part right here, which is 13.5. 68 plus 13.5 is 81.5. If the shop did 200 repairs this week, and this is a key question because I've seen this a lot. If the shop did 200 repairs this week, approximately how many of them took more than 2 hours? Well, first of all, we need to find the percentage that took more than 2 hours. If this is our 2 hours, more than that is 13.5 plus 2.35. 13.5 plus 2.35 is 17.85%. So we have 17.85% is more than 2 hours. Now that we have that, or another way that people say is this is 50% plus 34. is going to be 84%, so it's roughly 16%. Sorry, this is not 17. This is 15.85. Roughly 16%. My bad. This is why you always double check yourself. So now 200 repairs. I need 15.85% of 200 repairs. So I take the 200 and I multiply. I'm going to round this. I'm going to multiply by 0.16. So we're going to say that's 16%. And I'm multiplying by 0.16 because a percentage, you have to change to a decimal. And 200 times 0.16%, or 0.16, not 0.16%, but 0.16 is 32 repairs. This type of question is the type of question that is used more often than not. Hi, example 2. Sketch a normal curve for the following distribution. A mean of 45 and a standard deviation of 5. So first we're going to sketch our curve. I'm not the best at drawing bell curves. I apologize. The mean goes in the center. So that's our 45. 1 standard deviation away. Again, not the best, and that's okay. We add 5 because the standard deviation is 5. So 45 plus 5 is 50. 45 minus 5 is 40. 2 standard deviations away. Add 5, 55. Subtract 5, 35. And another standard deviation. We normally just go to 30 standard deviation, or 3 standard deviations. So this would be -1, -2, -3. This is a +1, +2, +3 standard deviations. We add 5, 60. And subtract 5, 30. Which means 99.7% of the data lies between 30 and 60. I don't know what this is for, but it lies between 30 and 60. Okay. In a set of test scores that are normally distributed, a test score of 70 is 3 standard deviations below the mean. And a score of 86 is 1 standard deviation above the mean. What is the mean of the data? Okay, let's talk about this. First, draw our bell curve. Again, not the best. So this would be our mean. 1 standard deviation, 2 standard deviations, 3 standard deviations. 1, 2, 3. And 1 standard deviation above the mean is, this is 86. This is our mean. So 1 standard deviation below, 2 standard deviations below, 3 standard deviations below, and 3 standard deviations below is a 70. Meaning I have 1, 2, 3, 4 standard deviations between 70 and 86. And between those I have 16 numbers. 86 minus 70 is 16. So 16 divided by 4, because each of these are evenly separated, is 4, meaning this would be 82, this would be 78, and this would be 74. See how they're all 4 away? Up here they were all 5 away from each other. And that means our mean is 82. All right. Now, this next page is your assignment, but I'm going to help you get it started. So, the bell curve. In the United States, the average height of an adult male is 5 feet 9 inches, meaning 69 inches. Male height is distributed according to a normal distribution curve, with a standard deviation of approximately 2.5 inches. Label the graph at the right showing the mean and the respective standard deviation values along the bottom. So if this is 69 inches, you can put the 2 hash marks for inches. And the standard deviation is 2.5. We add 2.5, we get 71.5 inches. Add 2.5, we get 74 inches. Add 2.5, 76.5 inches. Now this is 6 foot 2.5 inches. So if you're above 6 foot 2.5 inches, you are statistically significant right now. Now we're going to subtract 2.5 and we're going to get 66.5 inches. Another 2.5 and we'll get 64 inches. And another 2.5 and we get 61.5 inches. Now this is like 5 foot 1.5 inches. So if you are less than 5 foot 1.5 inches, you are also statistically significant because you're not within 3 standard deviations. Okay, now that we did that, you are going to do questions 2 through 11 as your assignment today. So make sure you draw in your lines and you answer each question, and then you'll send me a copy of this when you are done. I hope you have a great day.